Welcome back, focused learners. If you're a computer science student gearing up for your exams, well, you're in exactly the right place. Today, we're going through the ultimate exam prep explainer. I know how totally overwhelming it can be to stare down a massive syllabus, so we're going to break down these web architecture basics into highly visual, easy-to-digest concepts. So, get your notepads ready, because we are translating complex IT systems into clear, actionable knowledge you can take straight into test day. Okay, let's dive right into our roadmap for today. We'll start with the foundations, move into client-server apps and the three-tier architecture, and then decode HTTP and HTTPS protocols. Finally, we'll map out the web request cycle before putting you to the test with an exam review. All right, Section 1, Foundations, the Internet and the Web. Now, this is a distinction that trips up a lot of people, but it's absolutely crucial for your exam. The Internet is the actual underlying global network infrastructure. We're talking the physical cables, the routers, and the TCP/IP protocols. Fun fact, actually, the very first internet message sent back in 1969 was literally just the letters L and O before the whole system crashed. Now compare that to the World Wide Web, which was invented years later in 1989. The web is just one specific service running on top of that infrastructure using things like HTML, CSS, and web browsers. So think of it like this. The internet is the physical highway, right? And the web, that's the shops and billboards along that highway. Make sure you lock that distinction in. Moving on to Section 2, Web Apps and the Client-Server Model. In pretty much any web interaction, the client and the server have a very strict, well-defined relationship. The client, which is usually your web browser or a mobile app, always initiates the conversation. It's the active requester, and it's got limited local resources. The server, on the other hand, is the service provider. It literally just waits there to handle the heavy processing and store all the data. So bottom line to remember here, clients ask and servers provide. Now, a super crucial point for the test is understanding the difference between static and dynamic web apps. A static web app delivers fixed content. It's built purely with HTML and CSS, and it looks exactly the same for every single user. There's literally zero server-side processing happening. Dynamic web apps, though, they do some heavy server-side lifting. They use languages like PHP or Python to talk to databases, pulling in user-specific data so the content actually changes dynamically, based on who's logged in or even what time of day it is. And when we push those dynamic apps even further, we get into some modern application types you will definitely need to identify. First up, single-page apps, or SPAs. These load one single HTML page and dynamically update the content without ever doing a full, clunky page reload. Think about how incredibly smooth Gmail or Google Maps feels to use. Then we have progressive web apps, or PWAs. These act a whole lot like native device apps. They can work offline, and you can even install them directly onto your phone's home screen. Twitter Lite is an absolutely perfect multiple-choice example to memorize for this one. All right, let's jump into Section 3, the three-tier architecture. You can think of modern web apps as a sort of holy trinity. First, the front end, or the presentation tier. This is what the user actually sees, your HTML, your CSS, and UI frameworks like React. Next is the backend, or application tier. This is the brain of the whole operation, running something like Python or Java to handle the business logic and, do things like check your passwords. And finally, the database, which is the data tier where records are permanently stored. For your test, you've got to know this flow. A user's click travels from presentation, gets processed by the application tier, which then securely pulls data from the database and sends it all the way back. Next up, Section 4, protocols, specifically HTTP and HTTPS. So HTTP is the default, right? But the problem is it transmits data in totally insecure plain text over port 80, meaning if an attacker intercepts it, they can read absolutely everything. And that is exactly why we have HTTPS. The S stands for secure, of course. It uses SSL or TLS certificates to encrypt the data during transmission, and it specifically operates over port 443. Whenever you see a question on the exam asking about securing web traffic, immediately map port 443 to encrypted data and that familiar little padlock icon in your browser. But wait, before HTTP or HTTPS can send even a single byte of data, the underlying TCP and IP layers have to establish a reliable connection. They manage data transmission by executing this really precise three-way digital handshake. Here's how it works. Step 1, the client sends a SYN or synchronized packet. Step 2, the server replies with a SYN-ACK, basically acknowledging that request. And step 3, the client sends a final AK or acknowledgement. Only after this 1, 2, 3 handshake is fully complete does the actual web data start flowing. Once that data is flowing, the server talks back to the client using HTTP status codes. Now, I've built this high-yield cheat sheet for you right here. The 100-level codes, those are purely informational. 200-level codes mean success. A 200 OK is the golden standard you always want to see. 300-level codes mean redirection, telling the browser to look somewhere else. And 400-level codes mean the client actually made a mistake, like the infamous 404 not found or a 400 bad request. A really quick rule of thumb for you. 200s mean I got you, and 400s mean you messed up.
Moving right along to Section 5, the web request cycle.
From the very moment you hit enter in your browser, 6 distinct steps happen in literally milliseconds. To instantly lock this sequential order into your brain for the exam, I want you to use this goofy but memory-saving mnemonic. Uncles don't have super rare radios. Let's break it down. U for user action, D for DNS lookup, H for HTTP request sent, S for server processing, R for response sent, and the final R is for rendering the page on the screen. Uncles don't have super rare radios. Seriously, write that at the top of your test paper the exact second you sit down. And finally, Section 6, exam review and practice. Let's see what you've got. All right, here's practice question 1. Think about the very beginning of that lookup sequence we just talked about. What is the absolute first external server your browser reaches out to when it needs to convert a human-readable domain name into an IP address? Try to actively recall that very first link in the chain. Okay, question 2. Let's keep the pressure up. Once that initial server doesn't know the answer directly, it has to go straight to the top. So who does it query next? What's the name of the topmost server in the entire DNS tree? Moving on to question 3. We're going one level down the tree now. After the top server points the way, which specific type of server is responsible for handling domain extensions like .com, .org, or .net? Question 4. We are almost there. We've bypassed the top level and the extension level. What is the name of the final server in the hierarchy, the one that holds the definitive, official answer for that specific domain name? And question 5, bringing it all home. After traversing this entire complex server chain, what exact numerical piece of data is finally returned to the browser so it can actually connect to the website? Ultimately, what's the goal of this whole process? Okay, let's check your work against the answer key. Number 1, the browser first hits the DNS resolver. Number 2, the resolver then queries the root name server right at the top. Number 3, it asks the TLD or top-level domain name server for the .com part. Number 4, it finally hits the authoritative name server for the exact record. And number 5, it returns the IP address. Make absolutely sure you have this exact terminology memorized for test day. So we've covered the foundations, the architecture, the protocols, and the DNS chains. When you actually stop and think about the fact that this massive, intricate global architecture executes successfully in just milliseconds every single time you click a link, well, it's pretty staggering. But it leaves us with a provocative thought to end on. Considering how deeply interconnected all these sequential steps are, what happens to our global economy when just one tiny link in this massive chain fails? Definitely keep that in mind as you study. Good luck on your exams, focus learners, and I'll catch you in the next explainer.